I shall begin this lesson by defining the set of natural numbers, the set of integers, and reviewing the exponent laws for natural number exponents that you've learned so far in your mathematical career. Let's look at the set of natural numbers. The natural numbers are the numbers 1, 2, 3, 4, 5, and so forth. The set of integers consists of the set of natural numbers, 0, and the negative natural numbers. We shall use the same exponent laws we've learned for natural number exponents when we work with integer exponents. So let's review those laws. If we have a to the m times a to the nth, it is equal to a to the m plus n. As an example, if we have x to the second times x cubed, it is equal to x to the 2 plus 3, or x to the 5th power. Next, if we have a to the mth raised to the nth power, it is equal to a to the m times n power. As an example, if I have x cubed raised to the 4th power, it is equal to x to the 3 times 4, or x to the 12th power. If I have a product a times b raised to the nth power, it is equal to a to the nth times b to the nth. If I have x times y raised to the 5th power, the result is x to the 5th times y to the 5th. Next, if I have a quotient a divided by b raised to the nth power, it is equal to a to the nth divided by b to the nth, and of course we know b does not equal to 0 because division by 0 is not defined. As an example, if I have x divided by y to the 3rd power, then it is equal to x to the 3rd power divided by y to the 3rd power. Now, this last rule I want us to look at is if I have a to the mth divided by a to the nth, there are two different rules that I may use. One rule is that I will have a to the m subtract n, or I will have 1 over a to the n subtract m. And of course, once again, a does not equal to 0. As an example, if I have x to the 5th power divided by x to the 3rd power, I may say that that is equal to x to the 5 subtract 3, or x to the 2nd power. Now, when my exponent in the numerator is greater than the exponent in the denominator, then I use this first rule. But if instead I had x to the 3rd power over x to the 5th power, notice my exponent in the denominator is greater than my exponent in the numerator, then I use this second rule. It is equal to 1 over x to the 5 subtract 3, which is 1 over x squared. It is very important that you have a working knowledge of these exponent laws before you view this tape. In this tape, I shall work problems involving exponents that are 0 and exponents that are negative. I have divided this tape into 2 lessons. The titles of the lessons are 0 exponent and negative exponent. A blue screen will appear before the zero exponent lesson. Then I shall define zero exponent and work some problems. After I've completed the zero exponent lesson, a black screen will appear to denote the beginning of the negative exponent lesson. Next, I shall define negative exponent and work some problems involving negative exponents. Now let's begin with the zero exponent lesson and the blue screen. Zero exponent. I'd like to begin the zero exponent lesson by working two problems that will help us define zero exponent. Let's look at the problems. To begin with, we have 2 cubed divided by 2 cubed. Well, there are two ways we can think about that. We can think 2 cubed is 8, so we will have 8 divided by 8, and 8 divided by 8 is 1. Or we could have simply thought 2 cubed divided by itself. We know anything divided by itself is equal to 1, except for, of course, if we are dividing by 0. Division by 0 is not defined. But let's use our exponent laws to work this problem. I am dividing like bases, so I have a rule that says that I may subtract the exponents. So I will have 2 to the 3 subtract 3, which would be 2 to the 0. And what do I know 2 to the 0 equals? It is equal to 1. Let's look at x to the 4th divided by x to the 4th. Once again, I have a quantity divided by itself. Anything divided by itself is 1, unless we are dividing by 0, which is undefined. Let's use our exponent law. Our exponent law, since we are dividing like bases, tells us to subtract our exponents. So I'll have x to the 4 subtract 4, which is x to the 0. Notice, x to the 0 is equal to 1. Any real number or any quantity raised to the 0 power except 0 to the 0 power is equal to 1. 0 to the 0 is undefined. For our definition of zero exponent, we say a to the 0 is equal to 1. A does not equal to 0. Let's work some problems. To begin our problems, the instruction says to evaluate. When in mathematics we are evaluating, to evaluate means to find the numerical equivalent for an expression. So let's find the numerical equivalent for these expressions. To begin with, 7 to the 0 is equal to 1. Negative 9 to the 0. Does the 0 exponent apply to the negative 9? And because the negative 9 is in parentheses, then the 0 does apply to the negative and the 9. A quantity raised to the 0 power is equal to 1. Next, I have negative 2 to the 0. Does the 0 apply to the negative? The answer is no. If I want the exponent to apply to the negative, I have to write negative 2 in parentheses the way I wrote negative 9 in parentheses. This problem means negative 2 to the 0. So what I will have is a minus, and then I know 2 to the 0 is 1. So minus 2 to the 0 is equal to a negative 1. For this problem, I have 3 to the 0 plus 5 to the 0. 3 to the 0 is 1, plus 5 to the 0 is 1. 1 plus 1 would give me an answer of 2. For the next problem, the 0 is the exponent for the product 7 times a times b squared. As long as this product is not 0, and we will assume that that product is not 0, then the answer is 1. For this problem, I have the quantity x plus y raised to the 0 power. As long as x plus y is not 0, this 0 I know applies to everything in this parenthesis, so I know that this is equal to 1. Now, let's look at these two problems. The question is, does the 0 apply to the 4? The answer is no. If the 0 is an exponent for the 4, I have to write the 4 and the x in parentheses. What we mean by 4 times x to the 0 is 4 times x to the 0 power, which would be 4 times x to the 0 is 1, and 4 times 1 is 4. For this problem, the product 4x is raised to the 0 power. The 0 applies to both the 4 and the x, so the result is 1. For 2/3 raised to the 0 power, since the 2/3 is in parentheses, then the 0 is the exponent for the quotient 2/3. So 2/3 to the 0 is 1. For this problem, I have a negative, then I have 3 to the 0 divided by 4. The 0 exponent only applies to the 3. This means minus. Then in the numerator, I know the 3 to the 0 is 1, and in the denominator, I have a 4. So the answer for minus 3 to the 0 divided by 4 is negative 1/4. Now, I would like for you to work some problems. I would like for you to work these 3 problems. After you have worked them, I shall work them so you may check your work. Please pause the tape and work the problems. How did you do? Let's work these problems. The instruction is evaluate. 6 to the 0 is equal to 1. For the second problem, minus 6 to the 0 means minus 6 to the 0, which would be minus, and we know 6 to the 0 is 1. For this third problem, the 0 is the exponent of the x, not the 6. So this means 6 times x to the 0, which means 6 times 1, or 6. Now, before we complete this lesson, I would like for us to work one more problem. The directions would be simplified. You will see products like this when you work with negative exponents, and you need to understand what they mean. To begin with, the 0 is only the exponent of the y. So what this means is 5 times x squared times the y to the 0 times z. Now we know the y to the 0 is 1. So this means 5 times x squared times 1 times z. But what do I get when I multiply 5 times x squared times 1 times z? Well, 5 times 1 is 5, and then I will have x squared times z. Now, I usually do not go through these middle steps. What you need to do is recognize when you have a product like these, If one of the factors is raised to the 0 power, then 1 will take the place of that factor, and you don't really need to write the 1. The result is simply the other 3 factors, 5 times x squared times z. That completes the 0 exponent lesson. Let's begin the negative exponent lesson. Negative exponent. I'd like to begin the negative exponent lesson by working a problem that will help us define x raised to the negative n power. Let's look at the problem. I have x cubed divided by x to the 5th. We know that x cubed is equal to x times x times x, and x to the 5th is equal to x times x times x times x times x. We can say that x goes into x one time, x goes into x one time, x goes into x one time. That leaves us with 1 in the numerator, and in the denominator we're left with x times x, or x squared. So we know that x cubed divided by x to the 5th is equal to 1 over x squared. Now let's work this problem another way. If I have x cubed divided by x to the 5th, I may use my division law for dividing like basis and say this is equal to 1 over x to the 5 subtract 3 power. Well, 5 subtract 3 is 2. So this is equal to 1 over x squared, which of course is the same thing that I found the first way that I worked the problem. Now let's use the other division law for dividing like basis. X cubed divided by x to the 5th is equal to x raised to the 3 subtract 5 power. Well, 3 subtract 5 is negative 2. So we know that x cubed divided by x to the 5th is equal to x to the negative 2nd power. Well, these are all 3 the same problem, so they all 3 have to have the same answer. So x to the negative 2nd must be equal to 1 over x squared. And it is. By definition, x to the negative n power is equal to 1 over x to the n. Notice, x to the negative power goes to the denominator as x to the positive n power. Now, I'd like to state this rule in another way. I want us to look at what 1 over x to the n is equal to. I'd like to start by writing 1 over x raised to the nth power. Now, using our power of a quotient law, we know that that is equal to 1 raised to the nth power divided by x raised to the nth power. We know that 1 raised to any real number power is equal to 1, and we are left with x to the nth in the denominator. So 1 over x to the nth is equal to 1 over x raised to the nth. So we can say that this 1 over x to the nth is also equal to 1 over x raised to the nth. Notice, x to the negative n power is equal to 1 over x to the nth power, or we can take the reciprocal of x. The reciprocal of x is 1 over x and raise it to the positive n power. Usually when I am working with variables, I use this first rule, but when I'm working with numbers, very often I would prefer to use the reciprocal rule. So let's restate these rules. X to the negative n is equal to 1 over x to the nth, and that is equal to 1 over x raised to the nth. If I have a fraction, a over b, raised to the negative nth power, I may say that that is equal to the reciprocal of A over B. The reciprocal of A over B is B over A raised to the positive n power. Please notice, a negative exponent has nothing to do with the number being positive or negative. A negative power indicates a reciprocal. Now, I want to take this 6 to the negative second, and I'd like to use both these rules on 6 to the negative second. To begin with, I can say 6 to the negative second is equal to the reciprocal of 6. The reciprocal of 6 would be 1/6 raised to the second power, or 1/6 squared. When I square 1/6, I get 1 over 36. Using the rule that 6 to the negative second is equal to 1 over my base raised to the positive power, I would have 1 over 6 squared, and that would be 1 over 36. So you see, you may use either the reciprocal rule, or you may take the 6 and put it in the denominator and raise it to the positive 2 power, and we get the same answer. I would write both of these rules down. Now let's work some problems. Evaluate 8 to the negative second. Well, I can think that 8 to the negative second is equal to its reciprocal 1/8 squared. 1/8 squared would give me 1 over 64. Negative 3 raised to the negative 4th power. I may use the reciprocal of negative 3, which would be negative 1/3, or I may think negative 3 raised to the negative 4th power is equal to 1 over negative 3 raised to the 4th power. When I figure out what negative 3 raised to the 4th power is, I can think negative 3 times negative 3 times negative 3 times negative 3. Well, let's get the sign first. Anytime I raise a negative number to an even power, then the result is positive. And then 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 would give me 81. So my answer is 1 over 81. Now let's look at this next problem. Negative 5 raised to the negative second power. The question is, does the exponent negative 2 apply to the negative and the 5? For this problem, the negative 4 exponent applied to the whole negative 3. For this problem, though, we mean minus 5 to the negative second power. The negative 2 exponent does not apply to the negative in front of the 5. If we want the exponent to apply to the negative, we would have to write negative 5 in parentheses the way we did with negative 3. Be sure you understand what this means. Minus 5 to the negative second means minus, and then I need to figure out what 5 to the negative second is. That would be minus. Let's use the reciprocal rule this time. The reciprocal of 5 would be 1/5. So I want to square 1/5. I would have minus, and when I square 1/5, I'll have 1 over 25. All right, for this problem, I have separate terms, don't I? I have 4 to the negative first power plus 4 to the negative second power. For 4 to the negative first power, let's say that is equal to 1 over 4 to the positive first power. If you would prefer, you can use that reciprocal rule. For 4 to the negative second power, let's say that's equal to 1 over 4 to the positive 2 power. Once again, if you prefer to use the reciprocal rule, do so. What I have here is 1/4 plus 1/16. I get a 16 when I square that 4. Now I am adding fractions. I need an LCD. The LCD is 16, so I will multiply the 1/4 by 4 over 4. 1 times 4 will give me 4. 4 times 4 will give me 16. I am adding 4/16 to 1/16. The result is 5/16. Now, for this last problem, 3/5 raised to the negative second power, when I am raising a fraction to a negative power, I always use the reciprocal rule. I just think it's much quicker. So I will say that this is equal to the reciprocal of 3/5, which would be 5/3 raised to the positive 2 power. So now I need to square 5/3. When I square the 5, I get 25, and when I square the 3, I get 9. So my answer is 25/9. Let's evaluate 5 to the negative first over 5 to the negative second. Well, for 5 to the negative first, I know that that is equal to 1 over 5 to the first. For 5 to the negative second, I know that that is equal to 1 over 5 squared. So my problem is 1/5 divided by 1 over 5 squared would give me 25. So I am dividing fractions. To divide fractions, I write the numerator and I multiply by the reciprocal of the denominator. The reciprocal of 1 over 25 would be 25 over 1. I can say 5 goes into 5 once and into 25 5 times. I am left with 1 times 5 or 5 over 1 times 1, which is 1. Of course, 5 over 1 is just 5. For this problem, 2 squared is 4. 3 to the negative first power is 1 over 3 to the positive first power. My problem is 4 divided by 1/3. So I may say 4 times the reciprocal of 1/3. Well, we can think 4 over 1 times the reciprocal of 1/3 is 3 over 1. The result is 4 times 3 is 12 over 1 times 1. So my answer is 12. I would like for you to work these problems. After you have worked them, I shall work them so you may check your work. But please pause your tape and work these problems at this time. How did you do? Let's work those problems. To begin with, I have 7 to the negative second. I know that that is equal to the reciprocal of 7, which is 1/7 squared. 1/7 squared is 1 over 49. If you use the other rule, if you said 7 to the negative second power is 1 over 7 squared, you got the same thing, didn't you? For negative 2 to the negative fifth power, I will say that that is equal to 1 over negative 2 raised to the fifth power. That's 1 over, and now I need to figure out what negative 2 raised to the fifth power is. That's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Now this time I am multiplying a negative times itself 5 times. Since that's an odd number of negative signs, I know that I will get a negative answer. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So my final answer here is minus 1 over 32. For this last problem, since it is a fraction, for sure I will use the reciprocal rule. The reciprocal of 2/7 is 7/2, so I need to square 7/2. When I square the 7, I get 49. When I square the 2, I get 4. Now, let's look at variables raised to negative powers. Usually when we raise variables to negative powers, the instruction is simplify. What we mean for you to do when we simplify is to perform all possible operations, be sure that you reduce to the lowest terms, and do not leave any negative exponents. Now, you do not have to simplify using this order, but just be sure that with your final answer that you have done all three of these things. So let's begin with this first problem. I will use my laws of exponents. When I am multiplying like bases, then I add the exponents. So this is equal to x raised to the 6 plus the negative 2. That would be x to the 6 plus a negative 2 would be x to the 4th power. I have no negative exponents. I cannot reduce, and there are no other operations to perform. So this is simplified. Let's look at this next problem. Once again, I am multiplying like bases, so I know that I need to add the exponents. What's the exponent understood to be on this x? It's understood to be a positive 1, isn't it? So I'll say 1 plus my negative 4 plus 3. So I will have x to the 1 plus negative 4 is negative 3. Negative 3 plus 3 is 0. Now, what do we know x to the 0 power is as long as x does not equal to 0? X to the 0 power is 1. So my answer here is 1. First thing I think I'll do with this problem is to rewrite it. I have c to the negative 3rd, and I will multiply b to the negative 4th times b to the 6th. So I will say c to the negative 3rd times, when I multiply like basis, I will add the exponent. So for the b, I will have a negative 4 plus 6. So I have c to the negative 3rd times b to the negative 4 plus 6 would give me a 2. Now I have performed all possible operations, but I still have a negative exponent, so I need to clean that up. I know that c to the negative 3rd power is equal to 1 over c cubed, and I am multiplying that by b squared, and I will write the b squared over 1. So I will say 1 times b squared gives me b squared in the numerator, and c cubed times 1 gives me c cubed in the denominator. So my final answer is b squared over c cubed. Now let's look at this problem. I am taking the power of a power, so I know that I multiply exponents, so I will have x to the 5 times negative 3, which is negative 15, but I cannot leave that negative exponent. I know that x to the negative 15th is equal to 1 over x to the 15th. Now, for this problem, the first thing I'm going to do is rewrite it. Look at the z to the 0. The 0 only applies to the z, and we know that any real number to the 0, as long as the real number is not 0, is 1. So what this problem means is x to the negative 3 times y squared times 1, and all that is raised to the negative 5th power. But I don't need the 1, so I will rewrite this as x to the negative 3 times y squared raised to the negative fifth. Now, once again, I am applying a power to a power. So I will have x to the negative 3 times negative 5 will give me a positive 15, times y to the 2 times negative 5 will give me a negative 10. Now, I know that I cannot leave that negative exponent. I'm going to write the x to the 15th over 1, and I will multiply that by y to the negative 10th is 1 over y to the 10th. So I have x to the 15th times 1, which is x to the 15th, and 1 times y to the 10th, which is y to the 10th. Now I want you to notice what has happened. For this problem, I had c to a negative power, b to a positive power. Also notice that c and b are both factors. The factor with the negative power went to the denominator. The factor with the positive power stayed in the numerator. Look what happened down here. I have a factor of x to the 15th times the factor y to the negative 10. The factor with the positive exponent stayed in the numerator. The factor with the negative exponent moved to the denominator. Now, before we talk more about negative factors in the numerator and denominator, I would like for you to work these problems. After you have worked them, I will work them so you may check your work. But at this time, please pause the tape and work these problems. How did you do? Were you able to simplify these expressions? Let's work these problems. I have a to the negative 5th times a to the 7th. I am multiplying like basis, so I will add the exponents. I have negative 5 plus 7. The result is a to the negative 5 plus 7 gives me a 2. So the answer is a squared. For this second problem, I am raising a product to a power. So I will apply the power to both the x cubed and the y to the negative 4th. For the x, I will say 3 times 2 is 6. For the y, I will say negative 4 times 2 is negative 8. Now we know when we simplify that we can't leave the negative exponent. We will write x to the 6 over 1 times the y to the negative 8 we know is 1 over y to the 8. The result is x to the 6 times 1 is x to the 6. 1 times y to the 8 is y to the 8. Once again, notice what happened. When I have a factor raised to a positive power in the numerator, it stays in the numerator. Remember, I can think of this as being over 1. And when I have a factor raised to a negative power in the numerator, it goes to the denominator as a positive power. It moves to the denominator. Now, let's look at 2 more problems. I work these 2 problems because very often we confuse them. Look at them. They look a lot alike, don't they? Notice in this first problem, the negative 2 is the exponent only of the x, not of the 5. If I mean for the negative 2 to be the exponent for the 5 and the x, I have to write it in parentheses like this second problem. So what this means is 5, and I will write the 5 over 1, times an x to the negative 2nd is 1 over x squared. 5 times 1 gives me 5 in the numerator. 1 times x squared gives me x squared in the denominator. Notice I had a factor. It doesn't have a written exponent, but it's understood to be positive 1. That factor stayed in the numerator. The factor with the negative exponent goes to the denominator. Now look what happens here. The negative 2 power applies to the 5 and the x. So what this is equal to is 1 over 5x squared. When I square 5x, I get 25x squared. Now, let's look at the first rule that I gave you, and hopefully we're used to this rule now. X to the negative n is equal to 1 over x to the n, or if you prefer, you may say that x to the negative n is equal to the reciprocal of x, 1 over x raised to the nth power. Now I want us to use this definition, x to the negative n is equal to 1 over x to the n, to see if we can come up with a rule for 1 over x to the negative n. Well, that would be 1 over x to the negative n, we know is 1 over x to the n. Now I have 1 divided by 1 over x to the n. Well, let's write the 1 as a fraction, 1 over 1, times the reciprocal of 1 over x to the n. The reciprocal of 1 over x to the n is x to the n over 1. The result is 1 times x to the n, which is x to the n, over 1 times 1, which is just 1. Notice, 1 over x to the negative n is equal to x to the n. Now, let's see what we can come up with for x to the negative n over y to the negative n. I know that x to the negative n is 1 over x to the n. I know that y to the negative n is 1 over y to the n. Now, this is a division problem. 1 over x to the n times the reciprocal of 1 over y to the n. The reciprocal of 1 over y to the m is y to the m over 1. When I multiply this out, 1 times y to the m is y to the m. X to the n times 1 is x to the n. Notice, x is in the numerator with a negative power. It ends up in the denominator with a positive power. Y is in the denominator with a negative power. It ends up in the numerator with a positive power. I would like to say that it is understood that x does not equal to 0 and y does not equal to 0. Well, let's restate these as rules. You might want to write these down. Of course, this is the first one. 1 over x to the negative n is equal to x to the n. X to the negative n divided by y to the negative m is equal to y to the m divided by x to the n. And of course, it is understood that x and y do not equal to 0. Now, let's use those rules to simplify. By definition, 1 over a to the negative 5 is equal to a to the 5th. For the second problem, 1 over 4 times a to the negative 1 power. Now, does the negative 1 apply to the 4? No, it only applies to the a, doesn't it? Please notice that 4 and a to the negative 1 power are factors in the denominator. What I can do is I have a 1 in the numerator. I can bring the a to the negative 1 up as a to the positive 1 power as long as it is a factor. If it has a negative power, what that says is move me to the numerator. The 4 stays in the denominator because it has a power of positive 1. The result is 1 times a to the first, which is just a, over 4. I didn't really need this step, did I? For this problem, x to the negative 5 goes to the denominator as x to the 5th. Y to the negative 7th goes to the numerator as y to the 7th. There are no other operations I can perform, so this problem is simplified. Now let's see what we can do with this problem. Since you are dividing like bases, if you would like to use your subtraction rule for dividing like bases, you may, but I have found in my years of teaching that most students do a little better if first they get rid of the negative exponents. The x to the negative 3 goes to the denominator as x cubed. The x to the negative 5th goes to the numerator as x to the 5th. Now we will use our subtraction rule for dividing like bases. X to the 5th divided by x cubed would equal x to the 5 subtract 3, which is x squared. Usually, once we get these exponents to be positive exponents, then we can work the subtraction in our head, and we do a little better. On a division problem, when I have factors with exponents that are negative, usually I use the definition for x to the negative n power to move those factors. Then I perform the division. So for this division problem, I have a factor of 3 to the negative second power, a factor of x squared. In the denominator, I have a factor of 3, a factor of x to the negative 1 power. Let's move our factors that have negative exponents. 3 to the negative 2 power will go to the denominator as 3 to the positive 2 power. The x squared will stay in the numerator because it has a positive power. The 3 in the denominator will stay in the denominator because it's understood to have a power of positive 1. But the x to the negative 1 power will move to the numerator as x to the first. Now let's perform my operations. In the numerator, I am multiplying x squared times x to the first. I am multiplying like bases, so I will say 2 plus 1, and I will get x to the third power. In the denominator, I'm multiplying like bases also, but sometimes I think it's easier to say 3 squared is 9, and 9 times 3 is 27. So my final answer is x cubed divided by 27. Now, on this problem, because I am dividing and because I have negative exponents, I'm going to move my factors with negative exponents first. The 5 is a factor whose exponent is positive 1, so it stays where it is. X to the 4th has a positive exponent. The y to the negative 3rd has a negative exponent, so I will move it to the denominator as y cubed. In the denominator, my factor of 15 is understood to have a positive 1 exponent, so it will stay in the denominator. My factor of x squared has a positive exponent, so it will stay in the denominator. But my y to the negative 6 has a negative exponent, so it will move to the numerator as y to the 6th. Now let's see what operations we can perform. I have 5 divided by 15. Well, I can reduce by saying 5 goes into 5 once, 5 goes into 15 3 times. So I know I have 1/3. Since I will have other factors besides the 1 in the numerator, I will not write the 1 in the numerator. When I move to the x's, I have x to the 4th divided by x squared. Since I am dividing like bases, I will use my rule that says to subtract the exponents. Since the numerator exponent is larger than the denominator exponent, I know the x stays in the numerator and the power is 4 minus 2. For the y's, I am also dividing like basis. Once again, the power of y in the numerator is larger than the power of y in the denominator, so I know that the y will stay in the numerator, and I will use my subtraction rule to determine the exponent. I will say 6 subtract 3. So the power on my x will be 4 subtract 2 is 2. On my y, 6 subtract 3 is 3, and those factors will be over 3. Okay, are we ready for this? Well, for this problem, I have a product raised to a power times a product raised to a power. When I have a product raised to a power, usually what I do is go ahead and apply the power to each factor. So let's do that. I will apply the negative 2 to the 3 to the x to the y to the 5th. The 3 is understood to be to the first power, so I will think 3 to the 1 times negative 2 will give me a negative 2. For the x is understood to be to the positive 1 power. I will think 1 times negative 2 is negative 2. And for the y, 5 times negative 2 will give me a negative 10. Now I'm multiplying that by a negative 2 times x to the negative 3 times y squared. Now I need to apply the negative 3 to the negative 2. Now the negative 2 is understood to be to the first power. I'll put it in parentheses to be sure that I put the negative with the 2. I will think 1 times negative 3 is negative 3. For the x, I will think negative 3 times negative 3 is a positive 9. And for the y, 2 times negative 3 is negative 6. Now, here's what I'm going to do next. I'm going to rewrite this. I'm going to write my numbers raised to powers first, because those will end up being my coefficients. I'll have 3 to the negative 2nd times negative 2 to the negative 3rd power. Then let's write my x to the negative 2nd times x to the 9th times y to the negative 10th times y to the negative 6th. Now let's go ahead and write 3 to the negative 2nd as 1 over 3 squared. Negative 2 to the negative 3rd power is 1 over negative 2 cubed. On the x's, I am multiplying like basis, so I can say x to the negative 2 plus 9 times y to the negative 10 plus negative 6. Now, let's see. On the 1 over 3 squared, that would be 1 9 times 1 over negative 2 cubed would be negative 2 times negative 2 is a positive 4 times negative 2 would give me a negative 8 times my x to the negative 2 plus 9 would give me a 7 times my y to the negative 10 plus a negative 6 would be negative 16. Now, in the denominator, I have 9 times a negative 8, which is a negative 72. Let's put the negative in front of the fraction. Let's write the 72. I have x to the 7th. The 7 is positive, so the x to the 7th will stay in the numerator. I have y to the negative 16th. Because that 16 is a negative power, the y will go to the denominator as y to the positive 16th power. Let's just rewrite that. The answer here is a minus x to the 7th in the numerator, 72 y to the 16th in the denominator. Okay. Now this time I am simplifying, but please notice I have a division problem. I have a quotient. When I have a quotient raised to a power, I apply my power first. So let's apply this -2 to every factor in the numerator and every factor in the denominator. When I apply it to the 3, I will have 3 to the -2nd power. X to the 4 times -2 is -8. Y to the -2 times -2 is +4. In the denominator, I will have 5 raised to the -2nd power. X raised to the -4 times -2 will give me a +8. Y to the -3 times -2 is +6. Now, because this is a division problem, the next step that I will perform is to get rid of the negative exponents. I will move all factors, these are all factors in the numerator and factors in the denominator. I will move all factors that have negative exponents. The 3 to the -2nd will go to the denominator as 3 squared. The x to the -8 will go to the denominator as x to the 8th. The y to the +4th power will stay in the numerator as y to the 4th. The 5 to the -2nd power will go to the numerator as 5 squared. The x to the 8th will stay in the denominator as x to the 8th. The y to the 6th will stay in the denominator as y to the 6th. So notice what I did with these steps. I applied this power to each factor in the numerator and each factor in the denominator. Next, I took any factor with negative exponents and I moved it. Now I am ready to perform my operations. 5 squared is 25. 3 squared is 9. On my y to the 4th in the numerator, y to the 6th in the denominator, I am dividing like basis. So I will use my division rule. My division rule tells me that because this 6 is larger than that 4, the y's will stay in the denominator, and to get the power, I will subtract exponents. I will say 6 subtract 4. So that should take care of my division on my y's. For my x's are both in the denominator. I am multiplying in the denominator x to the 8th times x to the 8th. When I multiply like basis, I add exponents. So I will have x to the 8th plus 8. The result is I have 25 in the numerator. I have 9 in the denominator. The power on my x will be 16. 8 plus 8 is 16. The power on my y will be 2. 6 subtract 4 will give me 2. Okay, I would like to work one more problem before I have you try some problems. Once again, I am dividing. My -3 exponent applies only to the factors in the numerator. My 2 exponent applies only to the factors in the denominator. The first step that I will perform is to apply my powers to the factors in the parentheses. So I will have 2 to the -3 power. A to the 3 times -3 is -9. B to the -1 times -3 is +3. Over in the denominator, 3 raised to the 2nd power. Remember, I'm thinking my power here is 1. 1 times 2 is 2. A to the -2 times 2 will give me -4. B to the 3 times 2 is 6. So first I applied my powers. Next, I will move all factors with negative exponents. The 2 to the negative 3 will move to the denominator as 2 cubed. The a to the negative 9th will move to the denominator as a to the 9th. The b cubed will stay in the numerator because it has a positive power. The 3 squared will stay in the denominator because it has a positive power. The a to the negative 4th power will move to the numerator because it has a negative power. The b to the 6th will stay in the denominator because it has a positive power. Now I am ready to perform operations. Now usually what I do is figure out what my numbers are equal to first. 2 cubed is 8, 3 squared is 9. Now let's see what I'm doing with my a's. On my a's, I am dividing like bases. I have a to the 4th divided by a to the 9th. So I will use my division rule, which tells me to subtract exponents. I know that because the 9 is larger than the 4, that the a's will stay in the denominator and the power will be 9 subtract 4. On the b's, the 6 is larger than the 3, so the b's will stay in the denominator and the power will be 6 subtract 3. And what does that leave me for the numerator? It leaves me with 1 in the numerator. 8 times 9 will give me 72. A is raised to the 9 subtract 4 would be 5th power. B is raised to the 6 subtract 3 would be 3rd power. I would like for you to work these problems. After you have finished, I shall work them so you may check your work. But at this time, please pause the tape and work these problems. How did you do? Let's check your work. I shall work the problems. To begin with, we have a division problem raised to a power, and usually when I have a division problem raised to a power, I apply the power first. This power applies both to the x to the negative 5th and the x to the 3rd. When I apply it to the numerator, I will have negative 5 times negative 2 is positive 10. When I apply it to the denominator, I'll have 3 times negative 2 is negative 6. Now, by definition, I know this x to the negative 6 goes up to the numerator, and of course, since that's the only factor in the denominator, I'm left with what's understood to be a 1 in the denominator. When I multiply like bases, x to the 10th times x to the 6th, I add the exponents. So I will have x to the 10 plus 6, or 16th power. For this second problem, before I perform any operations, once again I'm dividing, and usually I move my factors with the negative exponents. I will leave my 45 where it is. My x to the negative 5th will go to the denominator as x to the 5th. My y to the negative 6 will go to the denominator as y to the 6th. My 9 in the denominator will stay where it is because it's understood to have a positive 1 power. My x cubed in the denominator will stay where it is because it's understood it does have a positive power of 3. My y to the negative 7th power will move to the numerator as y to the 7th. That's because it has a negative power. Now let's see what operations I can perform. To begin with my numbers, we mean 45 divided by 9, so I can say 9 goes into 9 once, 9 goes into 45 5 times. So I may write a 5 in the numerator. I don't need the 1 in the denominator because I'll have other factors in the denominator. For the y's, I have y to the 7th divided by y to the 6th. Because the 7 is larger than the 6, I know that the y's will stay in the numerator. I will use the subtraction rule, 7 subtract 6, to get the exponent. In the denominator, I am multiplying x cubed times x to the 5th. When I multiply like basis, I add the exponents. I will say x to the 3 plus 5. My result is 5 times y. 7 subtract 6 would be 1. I don't need to write the exponent of 1. In the denominator, I'll have x to the 3 plus 5 is 8. Now, for this last problem, I expect I'm going to need some more room here. The first thing that I will do will be to raise the 2x times y to the 4th to the negative 1 power, and then I'll raise the 3x to the negative 2nd times y to the 4th to the negative 2 power. So I will have 2 to the, it's understood to have a power of positive 1. 1 times negative 1 would give me a negative 1. X to the 1 times negative 1 would give me a negative 1. Y to the 4 times negative 1 would be negative 4. For the next parenthesis, I will say 3 to the 1 times negative 2 would give me negative 2. X to the negative 2 times negative 2 would give me positive 4, times y to the 4 times negative 2 would give me a negative 8. Now, let's rewrite this. Let's write 2 to the negative 1 times 3 to the negative 2nd, and then let's write our x's. X to the negative 1 times x to the 4, and then y to the negative 4 times y to the negative 8. Well, 2 to the negative 1 we know is the reciprocal of 2, or 1/2, or you can think of 1 over 2 to the first. 3 to the negative 2nd is the reciprocal of 3, or 1/3 squared, or you can think of 1 over 3 squared. Let's go ahead and multiply our like basis. We'll have x to the negative 1 plus 4. When we multiply like basis, we add the exponent. And for the y, we can say negative 4 plus negative 8. So let's see here. I believe I could go ahead and say 1/2 times, let's square that 3 to get 1/9, times x to the negative 1 plus 4 would give me 3, times y to the negative 4 plus a negative 8 would give me a negative 12. Now I will have 1/2 times 1/9, which would give me 1 over 18. I can think of that x cubed as being over 1, so I will have x cubed in the numerator, and I would have y to the negative 12, but y to the negative 12th would go to the denominator as y to the 12th. So my final answer would be x cubed over 18 times y to the 12th. That completes the integer exponent lesson. Please rewind the tape before you return it. Thank you.